All right, welcome everyone. Thank you for joining us today. We really appreciate you joining our web security training for developers session. We have some exciting content to share with you. My name is Craig. I'm a Java developer here at Portswigger. I work on our Burp Suite enterprise products. I have Mark with me as well, who is a C#.NET developer who works on our web team, part of our internal engineering team. Before we get started, just to let you know, we do have a team working in the background who are standing by to answer your questions. If you do have a question, you can use the Q&A facility, which is separate to the chat box. Just pop your question in there. The team will pick them up and answer them for you. We are going to try and answer all of the questions throughout the session. If we get a bit inundated and we don't quite get round to it, don't worry, we'll follow up with you after the session. And we'll also be making all the questions available as a document afterwards, and we'll be sending you a copy of the slides with all the links in for further information. So you should be able to just sit back, enjoy, and ask as we go along. We're actually going to cover today is talk through what Dastardly is and how it can help you as a developer. We'll talk you through how to deploy Dastardly into your CI/CD pipelines, and Mark's going to give us a demo of doing that with GitHub Actions. And we'll talk through a couple of the security issues that Dastardly can find out of the 7 key security issues that it is possible for it to find. So Dastardly is Portswigger's latest offering, and it's the first one that's aimed specifically at helping developers produce more secure software by introducing security testing into your build pipelines. Some of you might already be using static application security testing tools or SAST tools like semgrep in your pipelines, or you might be familiar with running other static analysis tools like checkstyle or stylecop. Static analysis tools work by examining your source code and looking for rule violations. In the case of checkstyle or stylecop, those rules are your coding standards. In the case of SAST tools like semgrep, they look for patterns that could lead to security vulnerabilities. Dastardly is different. Dastardly is a dynamic application security testing tool, or a DAST tool, hence Dastardly. And that means that it runs against your deployed site or application and attempts to prove that exploitable security vulnerabilities actually exist in your application, rather than just being a pattern that could lead to a vulnerability. Dastardly uses the same industry-leading browser-powered scanning engine that our commercial products do, but we've packaged it up in a way that makes it easier to integrate into your CI/CD pipelines that can give you results within 10 minutes or less. And like I said, we'll find 7 different kinds of security issue. Most importantly, it's completely free, so there's no restrictions on how many apps you can scan or how many scans you can run with it. The advantages of Dastardly are that it's platform agnostic. You can run it anywhere that you can run a container, so it's not tied to any specific CI/CD pipeline or tool. It's programming language and technology stack agnostic as well. So because it scans your deployed web application, it doesn't care how you built that application or what language or framework you used for it. It only requires the bare minimum of configuration. Basically, you tell us what to scan, which URL you want us to start at, and that's all you need to do. The results are presented in JUnit format, which most CI tooling can render into a nice report for you. The findings are typically reproducible and actionable, and we have remediation advice provided directly in the report itself. The advantage of running this type of scan in your pipelines is that you then can find vulnerabilities close to the point at which they're actually injected. And just like with unit testing or any other kind of pipeline testing, that reduces the amount of time you need to spend investigating and remediating the issues, because you've got a much better idea of the point at which those defects were injected. And because it's using the same engine as your security team or your external pen tester are likely to be using, you're going to be able to find and fix issues long before they begin their testing, which frees them up to find and remediate more critical bugs that might be trickier to find. So I'll hand you over to Mark so you can actually see Dastardly in action using GitHub Actions.
Thank you, Craig.
No problem.
Hi everybody, my name's Mark. I'm a .NET developer and I work in the web team here at Portswigger. So we have responsibility for the public website that you'll find at portswigger.net, and also some web endpoints like registration and updates for the Burp Suite tools, as well as a whole host of internal tools that we use here within Portswigger to kind of power the business. So what that means is, unlike Craig and his colleagues on the Burp Suite product teams, I'm not a security specialist by trade. My background is all .NET web development. So I was excited to have a try of Dastardly, see what it could teach me about vulnerabilities in my website, and figure out how to integrate it into my CI/CD pipeline. I like the thought that it would fail the build if it finds a vulnerability in exactly the same way as I'm used to a failing unit test or integration test failing the build, and therefore would kind of alert me to problems a bit sooner. You know, typically in my background, I've worked in situations where application security is not really the concern of the development team. It maybe belongs further downstream with a dedicated AppSec team or as part of the QA function. So what I've got to show you today is a very simple application that has some deliberate vulnerabilities in it. The site is hosted in GitHub, and it's built with a GitHub Actions workflow. So we'll take a look at the code that's had to be written in order to integrate Dastardly into that. We'll take a look at the site and see what it does and demonstrate what vulnerabilities we're looking for when we scan it. And then we'll take a look at the results of a build and show you what Dastardly is able to find for us and how it displays that to us. So let me switch over to here. I'm going to actually start in GitHub. So here's my GitHub project for the website. This happens to be written in .NET with C#, but as Craig has already mentioned, Dastardly is language agnostic, so that we're not going to be looking at anything C# or .NET specific in this session. Everything we're showing you today is equally applicable, whatever stack or language you're using. And likewise, although I'm using GitHub Actions to build this, the techniques that you're seeing today work well across a full range of CI frameworks. So the first thing I will do is make a small change to the site. Let's just add a word here into the README file, and that will trigger a build. So we can go and take a look at the GitHub Actions tab, and we should find a build has been queued up. There it is. So that's going to start running in the next few seconds. So while that's busy, I'll demonstrate the site to you and show you what that site does. So as you can see, it's a very, very basic website. It's got 2 pages apart from this welcome page. The first page has a cross-site scripting or XSS vulnerability. The second page has a cross-origin resource sharing or CORS vulnerability. Craig's going to go into a lot more detail later on after the demo about what those are. The CORS page is fairly basic and kind of hard to demonstrate visually, but much easier to demonstrate in this session is the cross-site scripting vulnerability. So we've got a very simple page here with a text input and a submit button. And when we add a message to the page, if the demo gods are smiling, there you go. The message just gets added to a list of messages at the bottom of the page. But the problem here is that we're not sanitizing that input, and we're just adding it to the page as raw HTML. So if I add an HTML tag in there and submit again, we should see that we get some bold text added to the bottom of the page. It's decided to stop behaving itself for a minute. This did happen when we practiced earlier as well, so don't worry about that. There it is. But now let's take a look at what happens if we add some JavaScript into there. Submit that. And that is the vulnerability that this website suffers from, and what we're hoping that Dastardly can find for us. So instead of just adding plain text to the website, it's injected some JavaScript into the page and run it in the browser. Obviously, it's a very trivial example here, but you could very easily imagine that technique being used to steal some customer session details or other sensitive information. So let's switch back to GitHub, and we'll take a look at what we had to do in order to integrate Dastardly into this build. I'm using GitHub Actions. If you're not familiar with GitHub Actions, it uses YAML syntax to declare the build steps that you want to carry out on your repo. Very, very similar looking to a range of other CI pipelines that you might be familiar with, like Circle CI and things like that. So even if you haven't seen GitHub Actions before, everything you're seeing here will be pretty applicable to whatever you're using. There's 3 sections to this build, or 3 parts to the build, which are known as jobs in GitHub Actions. The first one, starting there at line 10, is the build and test step. So this is using the .NET command line tools to build the project and publish it into a sort of deployable package. The second step, which starts down here on line 38, the second job is to deploy that to Microsoft Azure, and we're just deploying to a simple free web app for the purposes of this demo. But then the third, and you might notice the smallest section down here at the bottom, is the part that scans with Dastardly. So there's about 17 lines of fairly simple to follow YAML in there. And in fact, the 4 lines in the middle there, the core of it is these 4 lines here, 67 to 70. So what those lines are doing is getting the Dastardly GitHub action from the GitHub marketplace. So that's a pre-packaged action provided by Portsfigure, and executing it with one input, which is the URL of the site that we want to scan. So that's actually all you need to run Dastardly, those 4 lines at the bottom there. That will introduce Dastardly to your build pipeline. It will cause the build to fail if Dastardly finds a problem in it. The extra bit we've got below that is just kind of an added extra, really, and this is recommended in the documentation for Dastardly, which you'll find on our website and on the GitHub marketplace. It's just adding a sort of nicely formatted JUnit test report as an output to that step. So it gives you a lot more information about what Dastardly finds, and it formats it in a really nice readable fashion. So we'll see that in a couple of minutes. So that is it. Literally those 17 lines of code were all I needed to add to this project to add a Dastardly scan. There's nothing to install, nothing to license. There are no environment variables or secrets need to be declared elsewhere in the project. It's literally exactly what you're seeing highlighted on the screen there. So that's all the code we're going to look at. We'll just switch back now to the Actions tab. And yes, fortunately, our build has completed. You see there, it took exactly 4 minutes. And the build has failed. And it's interesting to note on this page, this is showing a history of builds run on this repo. Back when the repo was first created, and we only had one job in the workflow, which was to build and run all my tests, the build passed and we got a green build there. And likewise, when I added the next step to deploy to Azure, we were still getting green builds. Have a quick look at that. You can see there, build and test and deploy to Azure are both working fine. So it's only when we added Dastardly to the pipeline that we started getting problems reported. And I think it's fair to say for a lot of web developers, those steps of building, running our tests and deploying tends to be the extent of our build pipeline at times. So let's see what Dastardly has added to that by clicking into this latest build. And we can see immediately there's a third step in the build there. The first 2 steps have passed. Again, the build has worked, the tests have passed, the deployment to Azure has been successful. But now we've got a problem found by Dastardly. There's a little bit of information at the bottom of the screen of what it's found. It's found the vulnerabilities on both those pages on the site. If we click through into the build step, we can see the raw build log. And let's not scroll straight past that, because apart from some absolutely beautiful ASCII art at the top there to delight you with every build, we've got details of the error down at the bottom there. It's fairly short, it's fairly terse. It doesn't tell us a great deal, but it does tell us that it found vulnerabilities, and it's enough to fail the build and cause it to go red. But up here on the left, you can see a different representation of our build steps. And we'll take a look now at this 4th step, and this is going to correspond to that additional optional chunk of config right at the bottom of our YAML file. So this is the kind of nicely formatted JUnit test that Craig and I have both mentioned. And you can see it's run some tests. So 9 of its checks have passed, but 3 have failed. We've got a sort of dashboard view of those 3 problems. And if we click on raw output under there and take a look in at the full output that Dastardly has produced, you can see some real added value in here, apart from the summary section at the top, where it tells us what vulnerability it found, how severe that vulnerability is, and whereabouts on the site it found it. It adds a whole load of detail below that, which for me, particularly as a web developer, was really valuable and you know, kind of very useful to me. It's giving me a load of detail about the issue it's found, the background of that issue, what makes it so severe, and also a recommended remediation for fixing that kind of problem. So this is the kind of information you'll find for free also on our Web Security Academy over at the Portsfigure website. But here it's kind of there right in our build. So when we see a build has failed and we step into that to investigate why, it's giving us, I'm sure you'd agree, quite a lot more information than your average build failure. So it's kind of educating us as web developers on application security issues and hopefully kind of helping us to become better developers as a result. So that's it. That's all I had to demonstrate to you today. We've seen Dastardly in action on a site where we can all see there's a demonstrable problem. And we've seen the results that Dastardly is able to produce for us. Just to remind you that the Q&A function, which is separate to the chat function in Zoom, is still active, and we've got a whole support team taking your questions. So if there are any questions off the back of that demo, please do share them on the Q&A and someone will get back to you. And for now, I'll just hand you straight back over to Craig to carry us on with the presentation.
Thanks, Mark. So as we saw in Mark's demo, XSS and CORS are 2 of the security issues found by Dastardly in our vulnerable website. So some of you may already be familiar with what XSS and CORS are, but for those who aren't already familiar, we're going to give you a quick high-level overview of what they are and what impact they can have on users of your web applications. So we start out with cross-site scripting, and this allows an attacker to execute arbitrary JavaScript in a victim's browser, as Mark demonstrated. This potentially allows the attacker to carry out actions that their victim is able to perform and to access their data. So we're specifically looking at reflected XSS in this case. And these exploits occur when an attacker creates a malicious URL that we have up here, and then uses email or social engineering tricks typically to lure the victims into visiting that URL. When the victim clicks the link, they unwittingly reflect their malicious content through the vulnerable web application back onto their own computers, and then the malicious script can perform actions as that user, as the victim. And that allows them to potentially access the user's personal information, such as card details or other things like that, or to take over their account by stealing session cookies. So if we have a quick look at how you might inject one of these vulnerabilities into your application by accident, we've got a little bit of template code here that takes an employee ID number from the request and then reflects it back into the page. And it does so without doing any kind of escaping or sanitization. So some web frameworks will automatically escape or sanitize that for you, but not everyone's using those frameworks. And there are cases where that escaping can be disabled or it can fail without us as developers even knowing that somebody else somewhere else has done that. So just relying on the fact that it's going to do that for you automatically is obviously not as good as testing that it is happening correctly in your pipelines. So if an attacker was able to inject some JavaScript into the page like this, then they'd be able to siphon off session cookies, which then allows them access to the victim's authenticated session, and that's how they can perform actions as if they were that particular user. Cross-site scripting is extremely common in the wild. In 2020, it accounted for more bug bounties than any other security vulnerability. It comes under injection on the OWASP top 10 vulnerabilities, and injection is currently number 3 in that list. So again, it's very high profile and high priority. OWASP, when they tested websites, found 94% of the websites they tested were vulnerable to some form of injection, and 3% of those sites had been exploited in that manner. And there's a list of household names underneath of companies that have publicly disclosed XSS vulnerabilities in the past. So it's not just us, we think we might be in a smaller development team or a smaller company thinking we might get these things wrong. Even the big guys get it wrong from time to time. So testing and making sure that you're not vulnerable is obviously the way to go. And so the other issue that we found in the vulnerable app was a cross-origin resource sharing, or CORS vulnerability. And CORS is a browser mechanism that allows controlled access to resources that are located outside of a given domain. So it's useful, or it's needed for interacting with subdomains or with third-party sites, but it does provide the potential for cross-domain attacks if a website's CORS policy is poorly configured or poorly implemented. So if we have a look at this example, we've got an application that needs to provide access to other domains. The sort of right way to do this would be to maintain a list of allowed domains, but then you need to maintain that list, and you need to make sure that if you want to give access to another site, you've got to add things. If a domain changes, you need to make sure that you update the list to do that. So what the developers have done in this case is they've taken the easy route and effectively allowed access from any domain by reflecting the origin header back into the response. So here we can see that we're allowing the origin from our malicious website. Worse still, they have also set the allow credentials header to true. And that means that those cross-origin requests, so requests from the malicious website, can also include cookies and be processed in session. So armed with this knowledge, an attacker can exfiltrate any sensitive information such as API keys or CSRF tokens from the response using a little bit of JavaScript like we have here, and then go on to cause all kinds of havoc. If you want to know more about these and other web security vulnerabilities, you can check out the Web Security Academy, as Mark mentioned before. It's another free resource that Portswigger offer with loads of information and advice about web security and all these types of vulnerabilities. And there's also a bunch of free sandbox labs on there that you can experiment with to get yourself more familiar with what these kind of vulnerabilities are and how attackers use them. So hopefully that's given you some insight into what Dastardly does and what it can provide to you. If you want to give it a go, Dastardly, we have a whole bunch of deployment instructions, not just for GitHub Actions, but also for TeamCity and for Jenkins. As you mentioned earlier on, it's platform agnostic. It's based on a container. So anywhere you can run a container, you can run this. Hopefully you will have enough information to go on to deploy Dastardly into your pipelines, both from the presentation, which we'll send you a copy of, and also from the resources that are linked. And we have a little dare for you, a little challenge for you to take on. So as Mark demoed, it is really quick and easy to integrate. So there's no specific platform requirements for this. What we'd like you to do is see how quickly you can deploy Dastardly into your CI/CD pipeline, whatever that is, whether it's one of the ones we have deployment instructions for or something else. If you could record and send in a video of how quickly it takes you, you can post the video on YouTube if you like and send us the link to it. We'll then review these, and the fastest implementations will win some free Dastardly swag. So hopefully that's been useful for you all. Just before we close out today, we have a couple of poll questions that we would like you to answer. So we'll give you a few minutes to answer those, and then we will close out. Okay, that's great. Thank you for your feedback. We'll obviously take that on board. Like we said, we will send out a copy of the slides and a copy of the Q&A. And we're going to hold the question and answer session open for the next 10 minutes. So if you still have a question you haven't had a chance to ask yet, feel free to chuck that in there, and our amazing colleagues will be more than happy to answer them for you. And we'll see you again soon, and let us know how you get on with Dastardly. Thanks very much.